Hi guys, it's Miss Griffin again. We're taking a look at Unit 5, Skill 5. You're about halfway through with Unit 5. Hopefully you're doing okay so far. It's a lot of proportions. Today we're going to take a look at T-chart proofs again, bringing them back for triangle similarity. They're not as complicated as triangles congruent, so don't be scared off by that. Our essential question is, how can we prove triangles similar? When we use T-chart proofs, we only use AA. So that means we need to get or prove two pairs of congruent angles. And again, this will give us AA similarity. AA? Okay, so we've got this parallelogram, ABCD, and it's got this line going through it, EFG, and it has some diagonal DFB. They're just listing out the parts of this parallelogram for us. They want us to prove triangle DEF is similar to triangle BGF. Do me a favor, grab a highlighter and highlight the two triangles that we want congruent. So in this case, not congruent, similar, sorry. We want triangle DEF and BGF to be similar. Okay, so typically in these proofs, we would do a statement-reason chart, where your first statement is always given, your last statement, however many numbers down, would be triangle DEF, similar to triangle BGF. Remember that this would be because of AA similarity. But I'm going to give you guys an alternate option, and I know that some of you guys have been using this for triangles congruent in the past, and it's just kind of like a bullet proof, or what we call a paragraph proof. You don't have to write it in paragraph form, you can write it in bullets, but it's just explaining in the way that we used to get angles. So here you do have to still start with the given. So parallelogram, ABCD. We have segment EFG and diagonal DFB. And then we put a because in there, and it's because it's given. So this would be like step one of your regular T-chart proof if you choose to do it this way. You can do it either way, it doesn't matter. Then the second statement would be whatever we can get out of this given. We have opposite sides in this parallelogram, such as DE and BG, which we know are parallel. So we're going to state that the whole sides, DA and BC, are parallel, but we can shorten them when we're just looking at the triangles. BC is parallel to DA, and it's because opposite sides in a parallelogram are parallel. Remember, you can't talk about those special kind of angles that come from parallel lines until you get your lines parallel. So you have to explicitly state it. So that would be like step 2. If you want, you could even number these 1, 2, 3. When we have parallel lines, remember that we can go for Z's, lots of Z's, we love Z's. These give us alternate interior angles. Z's can be sideways, don't be afraid of them. So sideways Z here gets us going like this. So the angles we care about are here and here. Remember that you can put a 1 and put a 2 in your proof. That's totally acceptable as long as you label it in your picture. So we're going to say for step 3, or bullet 3, it doesn't matter, angle 1 is congruent to angle 2 because, remember this because is essentially the line in a T-chart proof. I'm trying to make the comparison for you so that you feel able or comfortable to use either option. It's your choice. Angle 1 is congruent to angle 2 because alternate interior angles are congruent when lines are parallel. Now I do know that there's another pair of alternate interior angles in this picture, and they go with a backward Z. So I'm going to find them, outline them, and label them with their number. 3, 4. So I'm actually going to stick this right in here with the third step, angle 3 congruent to angle 4, because alternate interior angles are congruent. So I don't even have to write it out again. Now you could have chosen to do vertical angles, talking about 3 and 4 here instead, or you could even do 5 and 6, I don't care. You can talk about vertical angles being congruent. You still get the same answer in the end. Remember, to prove triangles similar in this format, we have a similarity because we have no side lengths. We can't compare sides. We can't set up ratios or proportions. So then we say that triangle DEF is similar to triangle BGF because a similarity. So again, very, very similar format as a T-chart proof. Anything that you see here in purple or orange in the case of the second part of number 3 would be on the statement side. Anything you see here in blue would be on the reason side. So again, either option is valid. The last part here for the same exact picture says describe a sequence of transformations that would map triangle DEF onto triangle BGF. Sketch each step in the sequence on the diagram. So we need to take our big triangle DEF and shrink it down to meet the size of the other triangle. And then we also need to somehow, move it without giving you the answer. Try to move it so that it maps onto its matching parts. So we want to map this old figure onto this new figure. And that's going to be important for us about the scale factor in just a second. Because when we talk about shrinking or growing, that's a dilation, and a dilation has a scale factor, and you always have to state the scale factor. And I'm actually going to jot that down off to the side. Must state scale factor. Of the dilation. You also have to state the center of rotation or the center of dilation, whether you're talking about one or the other or both. State center of dilations and rotations too. So first, we definitely know this has to shrink, so we're going to say it's a dilation. By some scale factor centered at some point. So if I want to dilate this triangle, I want to shrink it towards F, because F seems to be like a pivotal point in this picture. So we're going to center it at F. And if I'm stating a scale factor, remember that scale factor is always new over old. So we need a set of new sides over the set of old sides, such as BF over DF, because they match based on this. DF, BF. So I'm going to say dilation by BF over DF. If I could make an F. Centered at point F. Now I could have done say BG over DE, or I could have done GF over EF. It doesn't matter as long as you pick a pair of matching sides. So once we shrink it, it's now going to look like this. And remember, we are supposed to draw it, so get your drawing pencils out. We're going to shrink it, and it's going to go somewhere like this. I don't know exactly how big it'll be. Well, I do, because I know the scale factor, but I don't know, legitimate size. So just kind of guess where you think it's going to be-ish. D prime and E prime. And of course, F prime is just going to be at F because we're shrinking it towards F. Now we know that D has to map onto B based on this. D, B. D has to map on a B. E has to map on a G. So hopefully you're recognizing that this is a turn. And a turn is called a rotation. And in this case, we are rotating a certain number of degrees centered at a certain point. In this case, we're still centered at F, and we are rotating a full line. I don't know if you can see that, a full line, meaning 180 degrees. And there you have it. If you flip it over, we'll take a look at one more proof, I believe. And then you're on your way to proving your own triangle similar by AA all the way. Okay, so this one tells us that BD is parallel to AE. I'm going to state my first piece here. Again, you are welcome to do a T-chart proof. I'm going to do my left side in purple and my right side in red, in case you are trying to make the comparison between the two. So BD parallel to AE because it was given. Now our goal here is to try to prove triangle ACE, and I'm going to kind of sketch this off to the side here. ACE, similar to triangle BCD. And the reason I'm sketching it off to the side is because they're set inside of one another. And I know these bases are parallel. We do need like the combination of pictures, the parallel, like side splitter picture where they're together, and then the separate picture where they're, well, separate. So these parallel lines don't have any Z's. I can't find Z's. However, I do see this angle matches with this angle, and you can see that they're already marked congruent, which is kind of cheating on their part. But they're giving you a huge hint here that angle B is, well, angle CBD, rather, angle 1 maybe, is congruent to angle 2. So I'm going to state that angle 1 congruent to angle 2. I'm also going to put it on my redraw and mark it there too. And I need a because. And those kind of angles that match up with one another, if you recall, are called corresponding angles. Because corresponding angles are congruent when lines are parallel. If you choose to leave off this last statement, when lines are parallel, I guarantee you we will dock you points. I know it's annoying, but you have to write it because those angles are not congruent. They're not the same measure if the lines are not parallel. Now we could talk about angle D and angle E from both triangles, have them be corresponding, but I want to bring up a different pair. That would be totally acceptable, and then you got AA in step number 3. But I want to bring up something that I'm noticing here. I see all of angle C, and all of angle C is in both pictures. Angle C is shared between both triangles completely. Just like before when we had a side that was shared between triangles completely. If you have an angle that is shared between triangles completely, you get to talk about it. Angle C is congruent to angle C, and this is because of reflexive. Just like with that shared side. Now, some of you are like, well, I've tried to say angle C is congruent to angle C when I see a picture like this and angle C is in the middle, and then you mark me off. Yeah, we do. That's because these are not reflexive angles. That's because they are vertical angles. This is different. Angle C is completely shared in triangle BCD. Angle C is completely shared with triangle ACE. Okay, so it's a different type of picture than those vertical angles pictures. Okay, step number 4. Right now we have 2 pairs of angles that are congruent. 2 pairs of angles is enough to prove your sides or your triangles are similar. Triangle ACE, similar to triangle BCD. And my reason is because of AA similarity. Again, if you are doing a T-chart proof, this stuff in purple would be on your left in the statement section. This stuff in red would be on your right in your reason section. You are welcome to do a T-chart, or you're welcome to do this little paragraph proof, your choice. But you do have to make sure you always state the given, and you always end with the prove. You never write because prove. That doesn't happen ever, ever, ever. Okay, that's not a reason. Given is a reason because it was given to you. Prove is not a valid reason, so don't use it. Don't be that fool. Okay, Let us know if you have questions. Go back, revisit the video if you need to. Otherwise, get started on your practice, please. Have a good one.